In today's video, we'll be taking a look at Postgres cases. See you after the music. Hey guys, I hope you all are doing well. I hope you all are taking care of your loved ones. So in today's video, we would be mainly extending upon what we have been discussing in the last two videos about conditional expressions. So in the last two videos, I went into details about coalesce function and nullif. So today it's about cases, and I did it in opposite order because through the knowledge we gather from those videos, understanding case would be much simpler. I'd be going into detail about what are the different ways of invoking case statements in your queries. Then we would be taking a look at a condition, one of the condition which you have to make sure happens, which is all the argument types which you provide, the return type should be or eventually should return into same types. Finally, we would also be taking a look into nested cases, and then we would be taking a look into source code to understand what exactly is happening behind the scene in the source code of Postgresql. Before I do that, I would like to do some self-promotion. So I just launched the membership website for Teachmedatabase. Currently I'm covering Postgresql, but my plan is to cover everything related to databases, all sorts of databases, all sorts of popular databases, so that being a member, you are an expert in database programming. All right. Some plane is going outside, I guess. About this website, all the videos I would be posting, beginner, intermediate, high intermediate, would be available on YouTube. So if you want basics clear, if you want a functional understanding of databases, go check out the YouTube. You will have enough contents over there. But if you want deep understanding of the databases, if you want to have access to exclusive contents, to my notes, to my research, if you want to be part of the research which I do behind the scenes, which will also help you become better at databases, if you want to be part of the private group where all the members would share and contribute, and we would talk through problems, we would talk through mentorship opportunities in a group setting, we can have live QA, and you can have access to all of that, well, then you should subscribe. You can subscribe for free if you want access to all non-exclusive contents, and apart from that, if you want newsletter access, so that whenever I'm launching or adding a new videos, it gets right into your email, and you get to you wake up with a new educative video which helps you become a better a database expert or backend engineer, full stack engineer, whatever you want to be. Enough of the self promotion, and now let's get into the detail. Okay, so as always, I'm going to start by dropping this animals table, which might have been there because of older queries I would have run. So now here you can see I removed it. I was just okay, there you go. All right, the camera is working fine. So over here, then I would create the same table. There are three entries, mainly three columns: name, sound, number of leg, which you can see over here, text, varchar, and integer. So over here I have I think 5 insert statements, which is going to populate our database, actually table and the database, so that we can take a deeper look into case statements. So this is how the database looks right now. All right, cool. So case, what is this case? So first of all, I would pull up the Postgres documentation, public documentation about case, and they put all the conditional expression inside one bigger group, which is 9.17 conditional expression. Let me get to the current version. That would be better. Yeah, there we go. So you can see case, coalesce, null if, greatest list. I've already covered coalesce and null if. Case is right now, and maybe I will cover greatest and list afterwards. So case is part of conditional expression, and they provide a good, they do a good enough job of providing the proper documentation and the prototype of how you would be utilizing it. I would recommend you guys should read about it. The link would be in the description just for your help. Now, I'll be implementing case over here, and with respect to Postgres case, there is a small story. So the SQL standard, the Postgres started with allowing no arguments in case. That's the older way of doing that. But afterwards, people demanded a more succinct way of utilizing case. So then they added the new version, which is with arguments. Now both are supported, none of them are depreciated, so you can utilize both. So how do we invoke case? First of all, what is case? Case is mainly for checking a conditional expression. You know, if A equal to B, then you return something, just like switch statement. Or if you don't know about switch statement, you know, if, else, if, else, right? So this is for beginners, by the way. So if some condition is A equals, you know, hello, then you print out something, right? Else if A equals no, then you print out something. I'm just making this up, all right? So instead of this if else, case provides a much succinct way of doing this, where you provide case. I'll go with the first way of doing it with no argument, and then you provide an end, which is going to end the case block. Then you provide a when, A equals, I forgot what I did, but I don't know, hello, and then you add then the result, okay, whatever is your result. If you want to add more clauses, you just pretty much do A equals okay or no, then result 2. All right. The right way of doing it conventionally is to provide a default, which you provide over here, else none. Okay, so this is pretty much the simplest way of doing case and the easiest to understand. This actually transcends pretty much into the no argument, the first way of doing cases in PostgreSQL. So here, for example, I'm gonna select something from animals, and what would that be? What am I selecting? So it would be case, again same thing, end in my case block, when, okay, let's say sound equals a woof, okay, then dog, oops, let's say I did like this, okay. When lowers, actually, let me remove it. I don't want to confuse beginners, you know. When sound equals woof, I was trying to do a down case, but don't worry about it. When sound equal to woof, then it is a dog. When sound equals, I don't know, you tell me, moo, then it is a cow. Otherwise, I don't know what it is. I don't know. All right, easy peasy. Here I provided no argument. It's just case, and each of these clauses themselves have equals. Let's see the results. And the table was on the right side. This is the result. For dog, well, the sound was woof, so it printed out dog. For cow, it was moo, so it printed out cow. And for other cases, it printed out, I don't know. That was our logic. All right. There's like, it's not semantically, logically correct. I'm just showing you the way to do that, right? After utilizing this no argument way, users started demanding, hey, I want to use simpler, more succinct way of utilizing case statements. So then they added this. So I'm just going to copy the whole thing, and then I would make changes so it's more easier to understand what is the difference. So over here, there was no argument up, but I'm going to add an argument on which conditional are going to be run, which is sound over here. I can remove the whole equals check over here, and I can remove the whole equals check over here. Now you can see it's more succinct, it's simpler, less code, and it returns pretty much the same result. You know, the left side, right side, you can see it's pretty much the same. I'm going to close all these. Let me clear my terminal. It'd be good. Now, one thing you have to be careful about is that the then, whatever is returning from then or would return after, let's say you provided an expression over here, the types of the return should be same for each of the clauses. Otherwise, it will throw an error. What I mean by that is, for both cases, I'm going to take the second approach. If I do something like 1.1, okay, this pretty much will throw an error because it's saying invalid input syntax for type numeric. I don't know. So it evaluated this one, which was numeric, and the default was pretty much string. So, you know, it printed out, hey, I don't know what is this. Okay, same thing here. It evaluated the other two, saw like it was pretty much integer. Actually, it was pretty much float or maybe decimal. Yeah. And it saw this was, sorry, it was not float decimal. It saw that it was numeric, and then evaluated dog, which was a string, and then it said, hey, I don't know what is this. It's not the same argument return type. So this is one thing you have to be careful about, is that the argument type should be same. All right. Now let's take a look into nested cases. Okay, I'm just going to copy the whole thing because I don't want to write the whole thing again. Select case sound, just the same thing which we did above. Okay. Let me just copy the one which is working, so I don't have to waste your time on correcting something. So this was working. All right, let's see. Yep, it works. Pretty cool. Let me make it a bit bigger. All right. So I'm saying nested cases. Yes, in the result as well as the conditional, which is what comes after when, you can provide another nesting case. So you can do something like here, case, and remember it ends with end. What I'm going to do here is, you know, break it down on to separate lines so it's easier for you to understand. So remember how to do case. Let's say I want to use the argument type. Actually, let's check if I can mix and match, right? When number of leg equal to 4, then dog. Okay, and I'm just going to provide pretty much one clause and one default. Else, who this? All right. What animal? I don't know what animal is this. All right. Let's see. So for the first one, it was dog. Pretty much simple. And it evaluated only after woof. For the other cases, for cow, it evaluated this, and for other cases, it evaluated, I don't know. Let me try this. Okay. Woof. Then let's say this is cat. Okay. What do you think will happen? Yeah, it will return cat. Pretty simple, right? Now, I'm going to remove this whole thing. By the way, to make it simpler, easier to understand, yes, you can also add a bracket around. I like to do that if I'm mixing and like if I'm going to evaluate this code inside a different, maybe Rails or something. Why? Because now it's more clear what is happening. Okay, brackets, you can add a parenthesis. There's no issue with that. But here I'm going to remove all this. And remember, this was about the return type, which is the then return argument, the return result from the clause. Now what I want to do is I want to see if I could replace the conditional. All right. So let me add the whole thing over here. When case. All right. And we have it then. When number of leg equal 4, for the first one it will be 4, then cat, it will return, the sound will be, by the way, the then has to be the sound. So I can do a woof here, and then it will return a dog. As you see, it returned a dog. Why? Because the conditional inside when it got evaluated first by the parser, then analyzer, and then eval expression, which mainly runs your source code and returns the result. So as you saw, I nested a case inside another case, and the result of this case was put into the when, which was mainly woof for the first row, and in that case it returned dog. So it evaluated this, which returns woof for the first. For the centipede, it will return who this. And sound, who this is like there's no such sound as who this for centipede, so it will not, it will go to the default, which is else. All right. This is mainly to, don't worry about the details. The main point I was making is you can utilize a nested case inside another case in then result and in conditional when conditional. All right, cool. Now, the one thing I do want to add over here is this is pretty simple, right? This is like sound equals and so on. There is an equal, like there is a check here which will return a boolean, right? There is an equals and it will return a boolean and then it will evaluate. But how does this work? How do you think this will work? There's no equal really, right? What do you think really happens in the source code? So what happens over here is Postgres, it has parsing and semantic analysis phase. What it will do is it will parse your clauses, which is, by clause I mean this is a clause 1, okay, oops, and this is clause 2, okay, and so on. It will take in the parser and semantic analyzer will take in these clauses and convert these if the argument is given. If the argument is not given, it's pretty simple. It just evaluates this boolean, right? If the argument is given, then it takes in the argument, it takes in whatever you have provided in the conditional, it converts the conditional into this equal boolean expression. This is a boolean expression which will return in true or false, and that is then evaluated. So that is why it's possible for you to utilize both of them without any issue. Now you might think, does it mean this is faster because it gets evaluated? No. PostgreSQL has a lot of actually all the database management softwares, all the drivers, all the code are pretty smart, and they have optimization, a lot of optimization in place so that you don't feel a lot of performance issues. But yeah, this is how the one with the version which has the argument gets evaluated. It gets converted into Boolean just like this, equals by the parser and analyzer, and then it gets evaluated just like the case over here. Now you might think, all right, I get what you're saying, but how does it really work? Like, what is the logic behind it? What is the code behind it, right? What is the code? Now, if you just wanted to check how can I implement cases, this is it. All right, there are just 4 things. First, you can utilize no argument way of doing it. Secondly, you can utilize argument way of doing it. Third, you just have to make sure that return types should be same. And fourth, you can nest as many cases as you want. These are the main points to keep in your mind. All the world's program, all the world's code, no matter if it is fucking NASA code, if it is fucking created by a kid, it's just 3 types of entities. And that's why you don't see a goto, which is a 4th kind. And Dijkstra said, don't use goto. Otherwise, programs would not be able to be broken down just like mathematical, logical theorems could be broken down into smaller pieces and yet get solved. Having said that, let's take a look into the source code. All right, let's see if what I'm saying is right or wrong. So I've already opened the source code over here. I'm going to put the link down in the description if you are interested. Now this is written in C. If you don't have any knowledge about C, it's all right. I will walk you through this. If you do have knowledge of C, it would be awesome, because then you can understand really well what is happening, and you might also become a contributor to Postgres. All right. Now, if you know a little bit about C, there are mainly two kinds of files. One are header files where you define the prototypes and everything, and there is an implementation file .c. The header are .h, and the .c are actually the implementation, the logic, right? So any case, what it says, case expression, a case expression. The one we just did over here, this case, whenever Postgres parser analyzer sees the case keyword, the when keyword, it will pull up this struct. You can think of like struct like a class in object-oriented programming, mainly an entity with some property, object, and it will create an instance of the case expression, which will have all the arguments, all the list of when clauses, all the when clauses you have provided as the arguments. And each of the when clauses would be represented by case when, which is another node, which is another object, which is mainly a placeholder value for the result of your clause, your when clause. All right. So this is kind of the definition, the nodes which inside the source code of Postgres, how, like what actually handles. So there's kind of like object-oriented programming aspect to it, and case expression represent your cases, the whole expression, the whole block, and each of the clauses are broken down and stored by case when. Over here, exec eval case. This is your function in the source code which evaluates, which runs case after the optimizations have been done. So static datum, don't worry about it. These are like kind of like the default return type inside Postgres. So this datum, which is static type, it mainly evaluates this, where it takes the all the case arguments and case expressions and everything. The list is mainly the clauses. By that I mean, clause. So this gets converted to one clause. This is another clause, and so on. So what is happening over here? So for each clause in clauses, so it is going through each of your clause. You don't have to worry about these things. Let's get right over here. It evaluates the clause. Again, it does optimization. If the clause is true, all right, if the clause is true, if we have a true test, then we return the results and the case statement is provided. So if this is true and it is not null for a particular clause, when whatever you provided, the when condition returned true, the boolean expression returned true, then it returns the result of over here, this whole thing. It mainly exec eval expr, so it evaluates the expression you have provided, it evaluates the result of the clause, and it stops, it returns. For loop ends over here, so it goes through each of them and it sees, hey, is there any case where this is satisfied? It is true. It returns that. If not, it will go to the final, the default value, which is default result, which comes from your else statement, and it will evaluate the else statement and return the value. That's what is happening over here. Simple. If not, if nothing happens, if there is none false value inside your case statement, in that case what happens is it will return a null. All right, let me try without an else. Okay, what happens if I do? So there is no else, it returns a null, right? So why did that happen? Because this code handled that. So we provided when the first clause, when the sound is woof, so it went to the first clause, right? It checked, hey, is the sound null? Is the sound woof? It was not. So it went further. It went to this one. Is the sound mo? No, it wasn't. It came out of the loop loop through all the clauses, mainly two of them. Then it asked, hey, is there a def result, which is mainly default, available for this clause, for this case expression? There was nothing. So then this code would not be implemented. So at the end, this will be implemented, which mainly returns a null value, and that is what we are seeing over here. Okay, pretty simple. I hope it makes sense. So anyway, I really appreciate you tuning in. Don't forget to like and subscribe if you like my contents, and it will really help the channel grow and reach out and help out more and more people. See you next time. Bye.